South Dakota's educational effort to raise awareness about the importance of soil health continues. The USDA Natural Resources Conservation Service entered into a cooperative agreement with the South Dakota No-Till Association and iGrow South Dakota State University Extension for delivering these seminars with the latest soil health and productivity technology to South Dakota farmers and ranchers.
About the, I think that Mike and Brent did a wonderful job on the panel, and they're a little afraid. They're both on my board of directors, and they're just excellent board members. Dave Newhart series, another board member of mine. So we have a really good board at Dakota Lakes. The thing about Mike is he'll eventually have cattle because he got 2 daughters. He sends them to the University of Nebraska, and we're betting he's one of the 2 of them's going to bring home a cowboy, and that's really that's the thing that's really holding him up, see? So, a lot of what they talked about today sounds kind of goofy, but when my grandfather planted oats, he planted oats with sweet clover, and my father did the same thing. And when my grandfather ran his horse-drawn binder through his oats to bind it, make it into bundles, he threw dwarf Essex rapeseed out of a bucket between his legs out on the ground behind the horses on the bare ground. And then when they got the oats in shocks, they turned out to sheep because the sheep wouldn't bother that oats, and they would eat the sweet clover and the weeds. And then when they got the oats hauled off to the threshing machine, they could turn out the cows. This is not new stuff. It's stuff we've forgotten how to do. When I went into the South Dakota Hall of Fame 7 or 8 years ago, I made that exact statement. I'm going into the Hall of Fame doing the stuff I learned from my grandfather and my father and reminding people of what that is. The thing they did is tillage, but if you want to do tillage with a horse or a C tractor, you're welcome to all the goddamn tillage you can do right now. I've got one of those C tractors with an iron seat, narrow front end, and no radio, so you're welcome to use it. Dakota Lakes Research Farm is the reason we're here. It's owned by farmers, which is incredibly important. And as I said, I got an 11-member board of directors. That's wonderful. We do a lot of the funding of our research from the production enterprise, and we're going to talk a lot today about why we do what we do on our production enterprise. This is a photo of part of the farm, and then we've got some land up north. Most of this is Millboro soils, and then down toward the river we got some less dry soils, and up north it's all promise and opals, the real true vertisol. So we mostly have West River soil. We're on the, excuse me, on the wrong side of the river, but this is what it looks like from our land. It's mixed grass prairie. It doesn't look dissimilar from the stuff we were driving around on yesterday, just about 10 miles this way, in terms of trees and the ravines, and most of the rest of it just kind of a mixed grass prairie looking thing. And the soils were similar. A farmer manages ecosystems that take sunlight, water, and carbon dioxide and makes them into products to be sold. We got so many people that think they're wheat farmers or cow farmers or corn growers or soybean growers or whatever, and forget what their true mission is, and it's to manage that ecosystem and take this sunlight, water, and carbon dioxide. Doesn't say anything here about nitrogen, and make them into products to be sold. And Gabe talked about, and so did Ray, talked about carbon. That's what it's all about. It's about harvesting the sunlight, turning it into carbon compounds that drive the ecosystem. There's 270 to 350 parts per million carbon in the air in this room. Used to be about 180. In a few years, there's going to be about 400. But 400 parts per million, there's almost 800,000 parts per million nitrogen. So just think of that, 280 to 800,000. So that's what they're talking about. We're all hung up on nitrogen, but it's really all about driving that energy, and that energy that goes in the soil is what's used to bring the nitrogen out of the atmosphere into the ground. So what we're doing is we're managing ecosystem processes. That's what they're trying to tell you this morning in their fancy terms. We have a water cycle, an energy flow, mineral cycle, and community dynamics. Does rain feed plants and recharge groundwater, or does it run off and cause erosion and water quality degradation? Just look at your land and see what happens by rain. And that's pretty easy when you're in Iowa or you're in your Red River Valley. It runs off or it goes down into drain tile and it all ends up in the river before it does anybody any good. The Dakota Lakes Research Farm began to use diverse low disturbance, no-till, and cover cropping to control runoff from center pivots. We really didn't start with dry land in terms of our no-till system. Our no-till system started trying to make water go in the ground under pivots. This is north of Pierre, actually up around Gettysburg with the Missouri River. These guys would irrigate and the water would run back to the river. Not an efficient thing. They were putting on 1 inch of water in 40 minutes. We now put in 2 inches of water on in 9 minutes with no runoff. And if you've never been to the farm in the summer when we're irrigating, you need to come. Because once you see what we do with water, then you will change your mind about everything you do. The reason that happens is we have macropores. These large holes that are root channels and worm channels, not so big as badger holes. That's a real ultra macropore, right? The thing that they miss that they don't kill is rattlesnakes. We don't kill the rattlesnakes. We move them, but a rattlesnake kills mice. If you have badgers, it's because you have mice. So if you leave the coyotes alone, and if you leave the snakes alone, they'll take care of most of the problems for you. This is Eileen Kladifko from, I think she's from Purdue, and she had a graduate student that took some latex and poured it on the ground in a no-till field, and these are all the macropores, the large wormholes and root horns. So that's where the water goes in the ground in our system, and that's the way it goes in the ground in the prairie. You never worry about a prairie in terms of water going into the prairie, because it goes in unless it's overgrazed or poorly grazed. But a good grazing system, perennial, it'll take water like crazy. And it goes in the macropores. And a question today earlier that came up, somebody threw a softball to Gabe and he just whiffed it. But they said, what do you worry about cows being on field when it's wet. You never worry about cows being on a pasture when it's wet. Why not? Because a pasture has soil structure. Your fields don't have soil structure yet. And one of the reasons we haven't put livestock in Dakota Lakes until we're going to this coming year, start bringing livestock into the system, is till we had to get our soil structure to the point we felt we could do that.
This is being recorded.
That's fine. So, if you dye the water, you get this kind of a view, and it comes down and then soaks into these areas. And the roots will actually follow these channels. Here's an earthworm that didn't really like the color of the dye. If you have good soil structure, it'll first do this, and then the excess will come down in like that, but it won't run off. Energy flow. How much sunlight strikes green leaves and makes food for the ecosystem? Because that's what you're trying to do, is make food for the ecosystem and then take some for the humans if you want to. But in the old days, the food came to the ecosystem, nothing really left. And then how much falls on dead vegetation or bare ground? And you need to ask yourself that question. The Dakota Lakes Research Farm uses cover and forage crops to fine-tune crop rotation. It's one part of a big picture. To increase this carbon capture, sequester nutrients that would get away from us otherwise, to fix nitrogen like Gabe talked about, or encourage friendlies, which is Dan Forgey. You read Farm Journal, you see all the stuff with Howard Buffett Foundation Cronin Farm, but Dan Forgey's the guy we're writing about. He's also on our board, but he calls predators, these things that help us not have to use insecticides, as friendlies. We have not used an insecticide at Dakota Lakes in about 12 years. We haven't had to. Okay? This is what we did with our German summer student this year. If you want somebody that's pretty convinced that you should till everything at least 10 times before you plant a crop, get a German student. So he was thoroughly convinced I was totally mad and stupid and whatever, so we had him making clay seed balls. And if you don't know what clay seed balls are and you're really interested in this idea, just Google One Straw Revolution. And there's a little book there that you can read where this whole farming system where all they do is throw seeds coated in clay and peat and fertilizer and whatever into fields of growing crops, so when the first crop dies, the second crop takes off. That's one of the ways we're looking to make this cover crop thing easier for us, is to use clay seed balls. But we think we might also be able to do our main crops that way. So often people talk about no-till and say, well, it's really wet out there, it's hard to get it planted. Well, if you live in western South Dakota, being wet is a good thing, isn't it? So, if we could just go out there and float across it with a four-wheeler and spread out some clay seed balls and have our crop grow, then I really wouldn't worry about it being too wet. It's an engineering problem, not a biological problem. So here's some of our cover crops, and one of the things that Gabe talked about, and Ray as well, is we look to have a mixture, and there's stuff growing down underneath here. What you see here is cowpeas, mostly, and it's warm, and it's in wheat stubble, and it's going early. And you got a couple of fat farmers, me included. I'm fatter now than I was then. This was back in 2006, but the cowpeas are growing fine because it's in August. And as soon as it gets down to about 36 or 38 degrees at night, the cowpeas decide they'd rather be in Oklahoma, so they leave. Right? They just die. They go, no, it's too dang cold for me. And then the brassicas and things come on. And we will actually put in some at times that flower in the late fall like this to feed our predators. That, you know, to actually attract some insects that our predators will eat. Okay? And then the next year we'll plant in right into that. You see that brassica stem standing there yet. But move almost no residue, just like Gabe. See, it's not really bare soil, and there comes up the corn. Boom. That all was done with just one herbicide application from the time we harvested wheat until this picture was taken. It's really, like Mike Arnoldly said, it's not a complex thing once you have the system working, because you're smarter than the weeds and the bugs, okay? Mineral cycle, are the nutrients available for plant use and environmental services, which means building more organic matter, whatever, or have they been leached, eroded, or transported from the landscape? Ecosystems that leak nutrients become deserts. Saline seeps indicate you're leaking, and what you're leaking is your fertilizer nutrients. It's not salt. It is a salt. I used to teach chemistry. It is a salt, but it's stuff with nitrate. It's calcium sulfate, which is known as gypsum. It's calcium carbonate, which is known as lime. If your pHs are going down, it means you're leaking lime out of your system, right? Increasing pH indicates leakage. 1 unit train of soybeans contains 1 million pounds of phosphorus. Our governors and our political candidates rail about not having enough trains. And I know Jerry Cope likes trains because he buys stuff and sells it to other places, right? But if we only sell stuff, we leak out our phosphorus. We need to have more livestock in the state so we don't have to sell so much stuff out of state. Now that we're growing more crops with no-till and good rotations, we need to utilize that to keep the livestock here. You know, think think of where a lot of our calves go. And I said this 25 years ago. Our calves from the Fort Pierre livestock go to Oklahoma and Kansas to eat corn that's raised by using fossil fuels to pump water to irrigate corn, and they're pumping the water from an aquifer that's going dry. Right? And now our distiller's grain follows the damn calves to Oklahoma. I mean, it doesn't make any sense what we're doing. We need to be doing the livestock here, and maybe not in feedlots, maybe fatten them on fields. So here's the saline seed. If you don't use the water here, it's going to go down and come out here. Here's a thing we did with Cronin Farms last year as part of the Buffett thing that had to do with livestock. This is pearl millet and German millet and some cowpeas mixed together, and they're going to swath graze that. Their first crop they grew on this piece of land was oats and peas. So they grew the oats and peas. Those are harvested as forage in June, and then right behind the baler they're planting this stuff. And this was in September. And then as soon as they got that done, he came in and seeded winter triticale between the swaths. And the idea was to bring the oats bales back out and spread them out this way and use them to hold the fence so they could control these cows. And then swath graze all winter. And by just moving, you use those oats bales to hold the wire, the post for the wires. So you just, when you got to move, you just pull post out of a bale, move the whole fence over to the next row of bales. Fairly easy to do. They didn't get that part done because they'd already hauled the bales to the buildings. But I got one picture later where they cleaned this up pretty well, even though those cattle weren't controlled. But there's no sense in bringing them cattle in and bringing the manure in and then taking it back out. And the nitrogen from the urine, if you take it into the building, never makes it back to the field. Okay? Most nitrogen in feed hauled to the feedlot does not make it back to the field, and most nitrogen in feed consumed in the field remains there. It's a big deal. Do many species, great and small, have fairly stable populations of all ages, or does a population of just a few species fluctuate widely? If you do tillage, you go from having quite a bit of biology to having no biology to having quite a bit of bacterial biology, and then it crashes as soon as it runs out of stuff. It's just constantly doing this. I heard a really funny thing the other day. The governor of Minnesota is having a summit to try to figure out why there's no pheasants in Minnesota. I could have saved him a whole bunch of money. You know, if you're mowboard plowing the whole damn state, there's no pheasants going to be there. Right? They need residue, they need cover. Okay? Weeds and diseases are nature's way of adding diversity to a system that lacks diversity. And once you start adding cover crops and diverse rotations, and Mike Arnoldly mentioned this, his weeds problems kind of went away with diversity and lack of disturbance. And so what we did in the beginning, nature's efforts to add diversity can be countered by adding diversity of our own. Cover crops do that, and you put them in this bare space between weed and when you're going to go to corn or something. One of the things they do is compete with the weeds. They're a tool. Cover crops and forage crops, and I used to call these green fallows of forage crops instead of cover crops. They're a tool, not an end. We're kind of in this phase now when everybody wants to talk about cover crops. They don't do cover crops, they should be taken out and shot. What we're really looking at is just a way to help us do this diversity thing a little better, fine-tune, right? So they're a way to improve rotation, diversity, and intensity, meaning water use, while providing competition. Cover and forage crops provide the opportunity to increase both intensity and diversity in situations where production of a grain crop would not be possible. So after wheat going to corn, you're not going to do a second crop there. Season's too short, there's not enough water. Even if you irrigate, there's not enough time, right? So we can't do a grain crop. If we try to do a grain crop, it's going to be unprofitable or too risky. In humid environments, tall grass prairie or wetter, eastern South Dakota, Iowa, Minnesota, the goal should be to have something growing at all times. Where we have limited growing season, we need to do this with cover crops, not with double crops. In subhuman, that's what you guys, semi-arid and arid environments, cover crops can be utilized to increase organic matter and biological activity. We're somewhere between subhuman and semi-arid. Yesterday I had my web soil survey out, and they tell you in the name of what your soil is, what kind of moisture you have there. But you have to know their lingo. So the NRCS people here probably know it. I know it, a lot of farmers don't. But most of the stuff we saw yesterday around Rapid City, semi-arid, was really where we're at, right? They're all used to. So we're going to use this little extra time and moisture that we got to increase organic matter and biological activity. Now, 10 things to know about cover crops. Decide what you want to do before you start. And that sounds really obvious, right? But the first thing everybody does is they go in and they say, I want to do cover crop. What do you want to do? Well, I want radishes. Right? That would be one of the last things I would put out in most of my situations. They're too expensive. The holes are too big. If I'm going to use Nebraska, I'm going to use rapeseed. That's what my grandfather used. That's a good thing to use. It gives you more grazing, in my opinion, for the dollar. Okay? But figure out what you want to do. Do you need to get rid of some moisture? Do you want to change the color of the residue? If you got wheat stubble, you're going to go to corn. You want it warmer in the spring. If you grow a cover crop in there, you change the color from a light color, which reflects light, to a dark color, which absorbs light. Okay? That really helps you in the spring. Think of a cover crop as just another component as your rotation. You don't want it causing you problems. Using a mixture, like Gabe said, of cover crops allows meeting several goals simultaneously. Mixtures add more diversity, grow at different times, better compete with weeds, and optimize nutrient cycling, and do a whole bunch of other things. You can get a little too goofy and have too many. Everybody wants to have 12. And you go, why 12? I don't know. Somebody said we had to have 12. Think about what you're trying to do and then get a species in there to do that. One of our favorite ones is to use flax as part of something, because flax is stiff. It's a broadleaf, but it's stiff. And so it will catch a lot of snow over the winter. So if I use some moisture after wheat stubble going into corn the next year, it'll have that flax to catch a bunch of that back again. But it's dark colored, and it's also highly mycorrhizal. So it really jump starts the mycorrhizal system. And both Ray and Gabe mentioned this idea of having a legume feed a non-legume. So here's a silage corn with no nitrogen. Look at the nitrogen deficiencies there, right? Because we didn't put fertilizer on it. And then right next to there, we put soybeans between the corn rows. So the soybeans gave their nitrogen to the corn in return for carbon. Interesting. It doesn't happen when you do tillage. This happens when you do no-till and have mycorrhizae. And if you're going to cut this for silage or graze it, you've got better feed. We have a field that we've done corn on corn for 24 years now. And we are trying to grow alfalfa as an understory crop, as a perennial cover crop. And we're going to continue to work with that, where the alfalfa will feed the nitrogen. We're not trying to harvest the alfalfa. We're just using it as something that will suck deep nutrients up, bring them back to the surface so they don't escape, and also make some nitrogen for the corn crop. Creating conditions beneficial next crop is usually one of the primary goals. Water and nutrient management is another primary goal. Water used by a cover crop during the non-crop period can often be regained during the growing season because of better infiltration, reduced runoff, and improved crop-water relation. The big thing is we need to maintain the cover. And one of the things we saw the brassicas do to us, and Jason was involved in this, Jason Miller, is when we put too many brassicas in our wheat, post-wheat mix, it went bare, and it hurt our corn yields by almost 20 bushel an acre next year. So it isn't really the water that it uses, but the fact that it's bare now and we lose more water during the growing season to evaporation. I had a graduate student that actually grew up not too far from him, from here, from Belfouche, Mr. Hansen. And this is his data, okay? This is the water in the fall with different cover crops. And we got oats, millet, lentil as monocrops, cowpeas, radish, and a mix of all those. And then we have a check where we had no cover crop, and then we had these different mixes. And here B is chickling vetch, C is let's see, F is flax, P is peas, and C is canola, I think, and R is dwarf essence rapeseed. But you can see there's a big difference in the fall. Some of them use a lot of water, but if we maintain the residue, they all came back up by, this is in April, this was taken the 4th of November, and this is the end of April. Okay? So the water came back because it caught the snow. And the one that you see recovered really well is the thing with flax. Understanding rainfall patterns, water holding characteristics. Use your web soil survey, and I've got a program that will do this for you, and just email me and I'll send it to you. That helps you understand how to do, how much does your water hold, how much water does your soil hold. If your soil doesn't hold very much water, it doesn't do any good to try to put too much water in it, so use some right away. Cover crop seed must be inexpensive in terms of its potential benefits. Small seeds mean less volume per acre, requiring less tank fills. Large seeds grow better in heavy residue. Small seeds grow better on the surface, but I don't like surface broadcasting either. And just as Gabe said, the large seeds will help the small seeds get out of the residue. Using harrows or some kind of thing like that just doesn't make any sense. Okay? Now, one important goal is to use a cover crop to balance the diet of the soil organism. High carbon residue like wheat stubble or corn stalks requires low carbon or high protein. It's like feeding cows. Just think of your soil organism as little tiny cows, tinier than sheep. Cover crops to balance their diet. Low residue crops require high residue cover crops. So if you're coming out of something with lots of residue, put in something that's high in protein. Make that mix. It's more guesswork than science right now. Rotation, sanitation, and competition are tools that we use for pest control. Having livestock integration, here's some cover crops at Cronin Farms being grazed in the fall. We call this catch and release nutrients. I actually got this term from one of our farmers that's going to be on a program Thursday in Aberdeen. Okay? Here's Dan Forgy taking a soil sample. The cows are sitting there. He's a variable rate guy, so the cows are sitting there asking whether it's time to poop now or not. See, that's what's going on. Remember what we started with in the prairie. We started with something that had roots that went this deep and were this massive. And these are our 3 daughters, and they're all in college now, so they'd kill me if they knew we showed that photo today. But we're not even close to that in terms of matching what Mother Nature did with root systems. So we started with this wonderful factory in the soil, and we've been mining it for years. And this is the problem. Here is a photo we took, and a lot of you have seen this in Afghanistan. Afghanistan, this used to be the Hindu Kush. This used to be all trees. And they cut the trees down, and they needed just a little more energy, just a little bit more, one more time, right? And now the only place they can grow anything is down here. Is this no-till? No, there's no residue. He's got a cedar that works okay. Where did the residue go? Abdul took it. And if you look real closely, he pulled it up by the roots. And he's going to haul it away, because if he doesn't, somebody else will. But we've got the U.S. government that's actually encouraging people to take corn stalks out and make ethanol out of it. In Iowa, where they're already doing tillage. And they put them on their semis or their straight trucks and they take them into the building. Because this is what he's going to, it's all he has to feed maybe the goat that his kids get milk from. We're not in that situation, but let's not get into that situation. Here's Argentina in the late 1990s. They did 7 years of pastures and 7 years of cropping. And when they crop, they use cover crops and diverse rotations. And here's the cover crop versus no cover crop. You can see that difference there. But look at the soil. This is what Ray wants to see when he sees the soil. And then the Argentine government outlawed the sale of beef, the export of beef. One of the reasons you have good beef prices in the United States, the Argentines don't export anymore. And so all the farmers had to quit, a lot of the farmers had to quit doing beef because there's not that much beef eaten in Argentina that for all their production. They had to export to make it work. So they quit doing beef production, went to doing all grain production, and don't do this anymore. The reason that the government did that is they want more taxes. Okay? This is that same location in 2006. 2010. Just totally destroyed that soil in less than 10 years. Within all textural groups, as organic matter increases from 1 to 3%, available water holding capacity doubles. Right? Seen all these. Water storage capacity is low. If you have low water holding capacity because you've degraded your soil, much of the rain that falls during extended periods of precipitation is lost. In contrast, a high water storage capacity combined with effective capture rain, macropores and things, and snow melt over the fall, winter, and spring can support crops during an extended period of drought. Okay? Cover crop, planting winter wheat into cover crops that are dying, and they're going to feed their nutrients to the wheat that's coming up. All tillage tool destroys soil structure. All tillage tool decrease water infiltration. All tillage tools reduce organic matter. All tillage tools increase wheat. Tillage is to agriculture what fracking is to petroleum. Okay? Think of what fracking does. It breaks apart that shale so more of the oil can come out. What tillage does is breaks apart the soil so we can get more of the nitrogen and organic matter to decompose to feed our crop. But they both increase the speed and extent of nutrient removal, both the speed and extent of nutrient removal from a resource, leaving the resource degraded. Tillage is to agriculture what fracking is to petroleum. I hope the camera's on. Continuous low disturbance no-till in combination with diverse rotations and cover crops. The biological answer to a biological problem. When we do tillage, we're looking backwards. When we're doing no-till, we're looking forwards. I got this from Sarah Singla in France. Thank you. Can we go home now? Any question? Yes?
Started out your conversation with the fact that carbon is increasing in our air. Is that correct?
Carbon's increasing. Yeah, carbon's increasing in the air.
So, in some people would think, like that carbon footprint, that is bad. Using that carbon to raise plants.
Well, yeah, but I think we grow plants good without having it at 320 or 400. In fact, when it gets up to 400, we're going to start having some issues because the C3 plants, which are mostly the weeds, will start having better growth patterns versus some of our C4 stuff to grow. But, you know, it's a different discussion than whether, you know, what we're talking about is a different discussion. Just the amount of carbon in the atmosphere right now relative to nitrogen is there's quite a bit of difference, always has been. But to take natural gas and turn it into nitrogen in Ukraine and ship it here and up the Mississippi River and then by train from Mississippi River to Rapid City, as compared to getting it from the air and into the ground, it's kind of a pretty obvious thing. That's kind of what I was trying to say. I think we probably better to try to learn how to do this. Yes.
One of your slides related to trying to use alfalfa as a kind of a perennial coming crop.
Yep.
Has anyone tried basically taking an alfalfa field and planting it in corn? Almost the reverse of that.
Well, it's almost the reverse of that, and I think it could work. The problem you have there, and now this is under irrigation where I'm doing it. Repeat the question. It says, anybody try to just plant corn into an alfalfa field without killing the alfalfa, basically what you're saying. And I'm not sure anybody has, but that will be a little bit tougher than what we did where we introduced the alfalfa later. And then we're keeping it alive from year to year. We probably got 4 years on it. It's getting pretty thin now. So what we're going to do this year is we're in 20-inch rows. We're going to plant 2 rows of corn, 1 row of alfalfa, 2 rows of corn, 1 row of alfalfa, 2 rows of corn. That kind of a pattern all the way across the field, and then leave the alfalfa in that 1 row, and with our precision or RTK and whatever, we can actually plant and leave that alfalfa alone. And we still have net 30-inch rows, so we'll raise our seeding rate up because we're now 30-inch rows in 20-inch pattern. And we're going to see if that works, because we have a little bit of an issue here with the alfalfa getting too much competition.
If you just let the alfalfa go to seed and graze it.
Yeah, well, the grazing part isn't. No, the grazing part would be fine. That'd be one of the advantages. Yeah. But if you let it go to seed before you planted the corn, that's one of the tricks we tried using here, is to wait a little longer till alfalfa's getting relatively mature and not as competitive than planting corn. But this really, there's a guy in Australia, you can Google grain and graze or pasture cropping. There's a guy in Australia that grows tall grass prairie plants. Big blue stem and switchgrass. They don't call them that, they call them kangaroo grass and something else. But big blue stem and switchgrass, he grows those in their hot, dry summer. And then he suppresses them during their rainy, cool winter and grows wheat and canola in the wintertime. And grazes the C4 grasses, the big tall grass prairie guys, he grazes them in the summer. So he's got grazing in one season and grain in another. So it's called pasture cropping or grain and grazing. So that, Colin Seiss is his name. It's an interesting thing as well. Thanks for coming. It was a good day. Thanks, Ruth.